In today's video, we'll be looking at part 2 of applications of parametric functions. Next problem, which talks about a football is thrown from the top of the stands 50 feet above the ground at an initial velocity of 62 feet and an angle of 45 degrees. Portion A of this question asks us to write a set of parametric equations that model the football's horizontal and vertical movement. Well, we're going to do the same thing we just did, or are we? Because now what we're going to do is we have a base equation for this question. And that base equation, which you should have in your notes, is HO plus VO, or V naught, sine of theta times t minus 1/2 gt squared. That's the base equation. Well, we need to split it into components. Remember, we have an x and y value, so we can split it into components. Well, if we split it into components, we get x of t, so that's our first base equation, is VO, or V naught, however you like to say it, V naught plus cosine, well, V naught times cosine of theta times t, and y of t equals H naught plus VO sine theta times t minus 1/2 gt squared. If you are in physics, you know that g should be negative 9.8 or positive 9.8 meters per second. In math, they use 32 feet per minute squared for g. So now what we need to do is substitute the values we know in our question into this equation. We already have our x and y components, so we're just going to substitute. So now we know our initial velocity is 62 feet per second. So now we have 62 times, which is our initial velocity, 62 times cosine of theta, or as our angle, which is 45 degrees, and that's it, times t. Well, now what we can do is we can look at our unit circle and say, hey, the cosine of 45 is, we can say that the cosine of 45 is about square root of 2 over 2, square root of 2 over 2, okay, and we know that's t, and we know it's cosine because cosine is the x, and sine is the y. So we know square root of 2 times 2, but remember we have that 62 in front. So your x equation, you don't really have to simplify it. This is the simplified form. X of t equals 62 times the square root of 2 over 2 times t. And that is your answer for the x of t. Now let's do our y of t. And if you remember, we wrote down the y of t equals h naught plus v naught times sine theta t minus 1/2 gt squared. Well, now what we do is we can substitute again, and let's use a different color now. So we know that h naught, h is representing your height, your initial height, that's why there's a naught. So you have 50 plus VO we said was 62 feet per second, plus 62 times sine of theta, sine is our y value of theta is still 45 degrees, times our t value, minus 1/2, and we said g is 32 feet per second. I'm just going to use 32, and then we minus 1/2 gt squared, so we use 32 times t squared. Okay, well now we can simplify this down. We know that sine of 45 is also square root of 2 over 2, so square root of 2 over 2 times 62 plus 50 minus 1/2 times 32 is 16 times t squared, and this essentially means we have 62 times square root of 2 over 2. Well, if we want to divide by 2, we can do that pretty easily. Well, 62 divided by 2 is 31, so we can rewrite the equation 50 plus 31 square roots of 2 plus or square root of 2 minus 16t squared, y of t equals, and that is our second equation. And so the equations for our 5a question are this x of t right here and this y of t right here. Let's combine those equations and put it up top so we can do b. Now that we have the work from the previous question moved out of the way, b says the football reaches its maximum height at t equals 1.37 seconds. Using your parametric equations from part A, which we just got, determine the location of the football at its maximum height relative to the starting point. Well, if you remember, we have a t in our questions. If you remember, we have, well, as you can see, we have a t in both of our equations, so we can just substitute in that 1.37 seconds for t. Pretty simple stuff. You can do this in your calculator, or you can do it by hand. There's also a t after 50 plus 31 times the square root of 2. There's a t right here, because we had a t in our base equation right up here for y of t. So we're going to solve for our y value now. Well, for the y value, we're going to substitute 1.37 in for t, and we have two t's in this equation, so we can just do that in our calculator or by hand, whichever is easier for you. And after substituting in 1.37 for t, we get an answer of approximately 80.03, and we know this is the maximum height, meaning it's going to be above the starting point because the question is asking relative to the starting point. So we're going to call it 80.03 above starting point. All right, now let's go ahead and do the x equation. Well, the x equation is 31 times square root of 2 times t, and we should get a value of 60.06 in the x direction, and then this 80.03 is going to be in the y direction. Okay, now that's how we would do number 5 and b. So our equations were y of t equals 50 plus 31 times square root of 2 times t minus 16 squared was 31 times the square root of 2 times t. And then we use those equations in order to solve b. And the last question for this video, it tells us that we are on a Ferris wheel that has a radius of 50 feet, and the bottom of the wheel is 3 feet above the ground. The Ferris wheel starts when you get on at the bottom and rotates counterclockwise, and has a period of 3 minutes. Create a parametric function to model your location on the Ferris wheel at a given time. It goes counterclockwise. Well, we know a clock goes this way, then goes like this. This means that the Ferris wheel goes this way every time it moves, going opposite of a clock. Well, to start this problem, I personally would draw a diagram just to get a good understanding of where we are on the Ferris wheel. So if we look at it, a Ferris wheel, let's say it's a circle, and then we know that we're 3 feet off the ground. So let's say that the platform is from here to here, and that's 3 feet. Since it's a circle, and they told us that we have a radius, and we know the radius is 50 feet. 50 feet. And we know that the period is 3 minutes. Period is 3 minutes. P equals 3 minutes. And now we need to find the parametric functions. Well, again, we're going to make a table of our 3 variables, as you should know by now, which are t, x, and y. Let's go ahead and write that down here. We have t, so in our first column, then x, then y. For our t, we know that we have a radius of 50. Well, now we want to divide 180 by 4. And we know our first point is going to be 0, so we're going to have a total of 5 t values, first being 0. So 180 divided by 4 is about 45, so we'll have our first real point after 0 at 45, then 90, then 135, and then finally back at 180. Let's go ahead and label the rows then in our table. We have 0, then 45, 90, 135, and then finally 180. Now we need to find the x and y values, which we are going to use the information provided in order to find. Well, what I like to do is call this central point our starting point. We're not in any type of box. We really don't have to worry about stuff like subtracting or adding. Well, now that we know our t values, we're going to try to figure out our x values. Well, we know that this 50 can act in both our x and y direction, but the 3 feet is only acting in our y direction. So our t of 0, so t of 0 is right here at our starting point. I'm going to call that central point the starting point. We need to find the x that we traveled. Well, we really haven't traveled any x. We haven't gone left. We haven't gone right. We're just at the center. So our t is going to be 0. But our y, we're always 3 feet above. So if you think of this as 0, 0, it's really 0, 3, because we're 3 above our origin, or 3 above the ground. So we're going to call y 3. Well, we know it takes a total of 180 seconds, or 3 minutes, to complete one whole period, or one revolution of the entire Ferris wheel, which now we need to divide into 4 segments, and we know it moves counterclockwise. We drew how a counterclockwise object moves. So we're going to say it starts here, and the first point is going to be right here at 45. This is going to be when it's at 45 seconds after the beginning point. Well, we can see that it moved from our central point to the right about 50. Well, it moved to the right, and since we're going counterclockwise, it's technically becoming negative. So we're going to go 0, and then we're going to call this traveling negative 50 this way. We're going to call right negative 50. So we have negative 50 because we know the radius is there. We're at our center. From our center, we went right 50 feet since that is our radius. So we went negative 50 in our x direction. But how about our y direction? Well, at our y direction, we're starting at the origin, but then we have to go up about halfway of the circle. But we know that the 50 feet is the radius, meaning from any point to the center in the circle, it's going to be 50 feet. So if we thought that the 50 feet starts from right here, at our origin, to the middle, and we can see the middle lines up with our 45, that's how high we went. Well, if we add 50 plus 3, we get 53, and that's going to be the y value for 45 t. So we have 53 as our y. Let's go ahead to 90. Well, we know 90 is right after 45. We're going counterclockwise, we're going this way. 90 is right up top. You can also look at this as the unit circle. So we have 90 up here. Now, at 90, we can see that our x really hasn't moved because we're still at that x point right at the center in our origin, where the x hasn't gone left or right. We're just going straight up. So our x is going to be 0. There's no moving left or right. But in our y, we can see that we went up a significant amount. We're at the top of the circle. Well, we know the radius goes half the circle, right? But we're at the top, so we're double the half. Well, if we double our radius, we'll get our diameter, which is the entire length of the circle. And if we double 50, we get 100, meaning that the diameter of the circle is 100. But that's the top. But we have to remember that we are raised 3 feet. So we have to add 3 feet to our diameter. Well, our diameter we said was 50. We're just multiplying our radius by 2 because we're going double the half length to get to 90. So 50 times 2 is 100. 100 plus the amount we're raised, which is 3, 103. Next, we'll go to 135. Well, 135 is right here. So 135 at x, we know that we move left. Well, since it's a counterclockwise direction, that is going to be our positive. And since we know our radius is 50, we know that we are still at origin, but then we moved left 50. So we moved left to the edge of the circle to 135. That means we traveled 50 in our x direction, and it's positive since it's going left. Well, now we know that our y, we moved up to the middle of the circle, and our y should be the same as 45 because we can see that they're aligned. Well, now, what was our y? How did we get it? And our y, we know that the radius is 50, meaning from any point from the edge of the circle to the center is going to be 50 feet. And since we know that from 135, or this edge to the center, is 50 feet. That's how we got x. But since we're looking at our y, we know that this segment from the center right here, or to the edge of the circle, is going to be 50 feet as well. And then we'll raise 3. 50 plus 3 is 53. That is our y value of 135. Finally, we're going to do our t value of 180. Well, if you remember from the clock question, the first and last coordinate points for a circle should be equivalent, and they are the same in this case. They're going to be equivalent, which is 0 and 3, because we know 180 is going to be right here. So we didn't move any x, we didn't move any y, except the raised part, which is 3 feet. Now that we've completed our table, it is time to find the parametric functions that accurately illustrate or describe this scenario with the Ferris wheel. Well, to do that, let's look at our data. Well, there's something interesting in our data. You can see that x starts at 0, goes to negative 50, goes back to 0, goes to 50, and then goes to 0. Well, this is pretty similar to a sine function, which starts at the origin, goes to the maximum, and then the origin, and then the minimum. Well, you can see it's reversed. It's going from the origin to the minimum, back to the origin, and then to the maximum, meaning that it's going to be a negative sign. Well, pretty easy stuff. So we're going to have our x of t equal our starting point, or our origin, which is 0, plus our amplitude. We can see we're going up 50 and down 50. Or you could do the equation, which is y max minus y min over 2. Well, we can see our y max, or in this scenario, is going to be our x max and our x min. So we can see our x max and x min. So our x max, we can see, is 50, and our x min is negative 50. So we have 50 as our max minus negative 50. 50 minus negative 50 is 100. 100 divided by 2 is 50, meaning our amplitude is 50. So 0 plus 50, well, we said it's a negative sign, so we can do a subtraction. So minus 50 times sine minus sine, and then here we're going to put our period. Well, our period we said was 3 minutes, and we know that, well, this is going to be your b value, and we know b equals 2 pi over your period. We said period is 3 minutes. Well, we're going to take this in minutes. We have b equals 2 pi over 3, and that's going to be what's in our parentheses, 3, and this is going to be all multiplied by t, because it's a parametric, and t is going to be a variable, so you can use this equation to find it at any point in time. Finally, we're going to do our y equation, so we have y of t, same process, but let's look at our data. We start at 3, we go to 53, then we go to 103. Well, we can see we're at pretty low in the spectrum, because at the end we return to 3 again. So that means our center point is somewhere at 53. Well, if we're starting at the bottom, we know that cosine starts at the max, goes to the origin, and then goes to the min. Well, we're starting at the min, going to the origin, and then going to the max, meaning it's a negative cosine. So we're going to do the same thing. Well, we're going to first find our c value, which is this value basically. And the equation for our c value is c equals y max plus y min over 2. We can do it for x of t if you don't know how to get it, because we have our min of negative 50, so we have negative 50 plus our positive 50, which is 0. 0 divided by 2 equals 0. That's why we got a c value of 2 for x of t. Now let's do the same thing for our y equation. Well, we have a y max of 103, so we have 103 plus our y min, which is 3, so we have 106 over 2, which means we have a c value of 53, so that's where our center line is, so that's where our c value is. Next, we have to find our amplitude. We said amplitude is y max minus y min, so we have y max minus y min. We said the max was 103, the min was 3, 103 minus 3 is 100, divided by 2 equals 50. So we know the amplitude is 50. We said it's a negative cosine because it starts at the min, goes to the origin, and then goes to the max. So we have minus 50, we said we got 50, cosine, same period, 2 pi over 3 times t. And that's basically it. This is the final answer to this last question. I hope this video helped. If you believe it did, please consider to like and subscribe. I would greatly appreciate it. We have made an Instagram, which should keep you updated on our latest videos. Comment below for any future video recommendations. Thank you.